you don't see the question clearly, just go to the ebook. And I'm going to try and write it as clear as possible. Okay, so the first question is number 2. I'm going to play with my lesson. So the first question is 2. And number 2, we have got 2 times 2a to the power of 4 cubed all over 16a to the power of 12. That's the question. Okay? Now, the first thing, when you have got a question like this, you have to remove brackets first. Okay? That's my suggestion. Before you do anything else, remove the brackets using one of the laws. So you can distribute these 3 among the integers here, which in this case is a 2 and the letter a. Okay? So you can end up having this will be equal to. Now these 2 here are going to leave as it is. I can write this 2 times. The exponent of this 2 here is a 1. So I can put that exponent there. Okay? So that when I multiply this 3 by the 1, I'll get 2 to the power of 3. Okay? And then this a here, its exponent is a 4. So 3 times 4 is going to be equal to a to the power of 12. Right? Then I can rewrite that at 16a to the power of 12. Okay, now when you get to this point here, there are many ways of carrying on. Okay, if you see that there is a base with an exponent in the numerator which is similar to another base and an exponent as well, you can just cancel out what? Those 2. So I can cancel out these 2. I can only do that if there is multiplication throughout in the numerator. Okay? If there was a plus here or a minus here, I cannot do that. As long as there is multiplication between the bases, then you can do what I just did. Okay? Okay. You see, if you have addition, let's say if it was 2 plus 2 to the power of 3, a to the power of 12, all over 16 a to the power of 12. For this case here, you have to find the common factor in the numerator first. Okay? You find the common factor which will be a 2, and then you take out the 2, then you can try to cancel out what the bases that are similar. Now for that case here, there is no addition or subtraction, so you can straight away cancel out this a to the power of 12 and that a to the power of 12 using law 2. Remember, if bases are being divided, you subtract the what? The exponents. Remember that. Now here, never ever cancel out, like in this case, the a to the power of 12 and the a to the power of 12, as long as there's addition or subtraction. Okay? Later on, I'm going to do an example where you have to factorize first. Okay? So here there's multiplication in the numerator. There's 1 term in the denominator. So you can cancel out that a to the power of 12 and the a to the power of 12. Once we do that, we would have eliminated the a. Okay? The a is gone. So we'll be left with this 2 here. Its exponent is a what? It's a 1. Right? 2 to the power of 1 times 2 to the power of 3 is going to give you 2 to the power of what? 1? 4. It will give you 2 to the power of 4. Okay? And this is a 16. We can write 16 using a base of 2, which will be equal to what? 2 to the power of 4. Now, because the base is the same, the exponent is the same, the answer will be a what?
1.
Okay, now there are many ways of doing it. I've done it this way, but this is not the only way. Okay, you could also convert this 16 here, whilst it's 2 here, to a base of 2. You can also convert this 2 to the power of 4 to a 16 and keep this 16 as it is there. You still get the same what? Same result. Okay, so there's more than one way of approaching it. Alright, as long as you use your laws correctly, use your mathematics concepts correctly, you show every step, then you'll be okay. So the answer there is a 1. Okay, any question? Yes?
How many marks is this question?
Maybe 2 or 3, but 3 marks now. Okay, let's move on to the next one. Now you can what I'm going to do is I need to open my test.
So you're going to say
Yes. Yes. Or as we speak, the video is being created. I'm going to make a PDF, send it on the book. Okay. All right. Let me move on to the next page. Now, the next page, I need my phone then. You're also supposed to have your phone in front of you. You need to open the book so that you see where I'm taking the question from. We are on exercise 1. So number 4 is 3a cubed times 5a to the power of 5 all over 5a cubed all squared. That's the next question. Now, you can see that in the numerator, there's multiplication. Okay, in the denominator, we only have one term. So, to carry on here, my suggestion would be, since there's multiplication, multiply the coefficients of the base A. Multiply the what? The coefficients. So 3 times 5 gives you 15. Right? Because there's multiplication here, a to the power of 3 times a to the power of 5 will give you a to the power of 8. Because you add the exponents if you're multiplying the bases. Okay? The denominator, I can simplify it. Right? Remember, the exponent of this 5 here is a 1. Okay? Then we have to use law number 3 to remove the bracket. So 1 times 2 gives me 2, so that becomes 5 squared. Okay? And what's 5 squared? 25. So I can write that here as 25. Then 3 times 2, that will give me a to the power of 6. Right? Now, let's simplify the integers. 15 over 25 is equal to what?
3 over 5.
3 over 5. So it means we can have write as 3 over 5. Since the base here is the same, that is a and a, but the exponents are different, means I can say a to the power of 8 minus 6 will give me what? A 2. Now, I can write the answer like this, or I can write it as 3a squared all over 5. It's the same thing. So if you stop here, it's fine. If you write it like that, it's also okay. I hope that you went over your laws of exponents. Then number 6, I'm not writing anything down. This is right there. So when I do more work at home, you end up doing more work at home. Because if you write it down now, it will be much better. Okay, we can write number 6. We have minus 2 times minus 4a squared plus b cubed all squared. Okay? Now, this one here, inside the bracket, how many terms are there? There are 2 terms because of addition. Okay? So, because of this addition, you can't distribute these 2 inside. Because there is addition. You can't distribute that exponent inside. You can only distribute these 2 if there was 1 term inside, and it was 1 term inside, or there were 2 terms that were multiplying each other inside that bracket. So if there's addition or subtraction, you can't distribute. So what we have to do, we go back to the basics of algebraic expressions that we did in grade 9 and grade 10. Okay? Remember, when you had something like this a plus b squared, okay, like this, how did you simplify? You use what? FOIL. You remember that? You use FOIL. So this was equal to a plus b times a plus b. Okay? If you simplify this using FOIL, if you are in grade 11, so I'm not going to start from scratch. So this becomes a squared plus 2ab plus b squared. To use FOIL. Okay? Alright? Now, here, I'm going to use a different color now. This minus 2, it affects everything inside the bracket. So what I'm going to do is, my next step, I'll say minus 2, open square bracket. Okay? Then I'm going back to grade 9. Right? I'm going to use FOIL. So this is minus 4, a squared plus b cubed times minus 4 a squared plus b cubed. Then I'll close the bracket. From my experience, I've seen it happening. Some letters will just distribute this 2. You end up having minus 4a to the power 4 plus b to the power 6. That's incorrect. Sorry? Yeah. This is the best way of doing it. Any question? Right, for now, I'm not going to worry about this minus 2, which is outside the square bracket. I'm going to use FOIL here. How many of you have ever heard of what is called a perfect square trinomial? You did algebraic expressions in grade 9. Right, there are 2 types of perfect square trinomials. Okay, let me see where I can write them maybe here. Trying to squeeze this here. There are 2 types. If I give you x minus say y squared, like that. If you remove brackets here, you must get x squared. Okay? You must get x squared minus 2xy plus y squared. It's called a perfect square. This trinomial is called a perfect square trinomial because when you factorize it, you get 2 identical binomials. Didn't your teacher tell you that? I told you last week. I taught you in my class. You've got it in your math workbook. If I taught you last year, I told you it's there in your math workbook. It is there. When you check your grade 10 in the math workbook. So this is the first trinomial, which is called a perfect square trinomial. Another one is one whereby you can have a plus like that. Then you square. If you simplify this, you get x squared plus 2xy plus y squared. These 2 are called perfect square trinomials, this one here and that one. They are both perfect square trinomials. So here, we can just use FOIL. Okay? We can just use what? FOIL. If I use FOIL, then I'm going to have minus 2 open bracket minus 4a squared times minus 4a squared. You get what?
16.
You get 16a to the power of 4. Because a squared times a squared will give you a to the power of 4. Remember, if you're multiplying bases that are similar, you add the what? Exponents. Then minus 4a squared times b cubed. I'll get minus 4a cubed, so a squared times b cubed. Okay? So I'm done multiplying this minus 4a squared by these 2. Now I need to multiply this b cubed by those 2. So b cubed times minus 4a squared, I'll get minus 4a squared b cubed. Then b cubed times b cubed gives me what? What's b cubed times b cubed? B to the power of 6, not b to the power of 9. You are multiplying bases that are the same. So you add the exponents. So 3 plus 3 gives you what? 6. So that's b to the power of 6. Then we close the bracket. Okay? Then from here now, we simplify what's inside the square bracket. So we have got like terms here. Those are like terms. So I can what? I can simplify. Once I simplify what's inside the square bracket, then I'll distribute the 2 inside. Okay? That's what I'm going to do. So my next step would be write minus 2 times 16a to the power of 4 minus 4a squared b cubed minus 4a squared b cubed. Alright. I know that a question like this can cause problems. When you want to simplify something like this here, forget about the letters. Concentrate on the coefficients. What is minus 4 minus 4?
Minus 8.
Minus 8. Then you just add those letters. That's all. So it will be minus 8, a squared b cubed plus b to the power of 6. I'm not done yet. I need to move the square bracket. So I'm going to multiply everything inside by minus 2. So I'll get minus 32 a to the power of 4 minus 2 times minus 8, that gives me a positive 16 a squared times b cubed minus 2 times b to the power of 6. I'll get negative 2 times b to the power of 6. And this will be my final answer. Okay, that is my final answer. And a question like this might have 3 or 4 marks. Okay. Any question? Any question? Yes.
And how come the atomics simplified and divide all the coefficients by 2?
I don't know about simplifying it. Huh? Okay, the final answer is not necessary to simplify. Not necessary.
In the video it says simplify the expression on the basis. So we have to simplify
It says what?
It says you have to simplify the expression to so we will be simplifying now.
I simplified it. It's simplified. Simplify the expression doesn't be without the what I've been doing until I got my answer.
No, I'm saying on the final answer.
No, you can't simplify it any further. You can't simplify the final answer any further.
Why not?
No, you're going backwards now. You're going backwards. You just stop here. You could simplify further if this was a numerator, there was another number, which is what? A denominator, then you can try to simplify. But it's more like it's a whole number. But in terms of letters, so you can't simplify it any further. Just stop. Don't forget, we are not factorizing. We are not factorizing. We are simplifying. That's all. Okay. Can I carry on? So if you have a question, ask. Because this topic is so important, it's actually a foundation of other topics that you do in this grade and next year in matric. Yes.
The last with the unfortunately negative significance.
No, it's negative 2b.
Or
It's negative 2b. You see this b here?
yeah.
Multiplied by negative 2 gives you minus 2b. Can I get on?
Yes.
Huh? Okay, the next one. The next one is number 8. Okay. We did a question like this last year in grade 10. Okay? The good thing about term 1 grade 11 is that most of the concepts we have got a foundation from grade 10. So if you grasp the grade 10 concept, you will not have major problems in grade 11. Okay? Now, I'm just going to ask to see who still remembers what you did last year. What would be your first step to simplify this? Yes, you convert all the bases to prime bases. You convert all the bases to prime bases. Now in maths, the most common prime bases are 2, 3, and 5. Those are the most common ones. Sometimes you encounter 7, but 2, 3, and 5 are the most common. Okay? So, I need to convert all the bases here either to a 2 or a 3, and if possible a 5. But here we don't have a base which is a multiple of 5. So I can't use 5 as a base. It's only 2 and 3. So I'm going to start with that 12. 12, now you have to know your factors of 12. Okay? Your factors of 12. 12, 2 times 4. Sorry, 3 times 4, rather. Okay? So I can write that as 3 times 4. And I'll put that in brackets. Don't worry, I'm going to simplify. I'm just starting from the basics. Okay? I wrote 12 as the product of a prime number and the perfect square. The perfect square, which is a 4, I can convert it to a base of 2. Okay? I don't want to rush to write 3 times 2 squared. So someone might get confused. So I want to do step by what? By step. Right? Times 27, you should all know that it's equal to 3 cubed. So 27, that's 3 cubed. Put that in bracket, the exponent is x minus 2. Okay? All over 80 now, that's 9 times 2. Okay, I can write that as 9 times 2, or I can write it as 6 times 3, but I'll in fact write it as a product of a prime number and a perfect square. Okay, the perfect square, which is a factor of 80, is a 9. So I can write this 80 as 2 times 9, all raised to the power of 2x minus 1. Okay, then now let me remove the brackets. Let me carry on the other side. That way. Now this 4 here, I can write it as 2 squared. This 3 is a 3, so I can write that as 3 times 2 squared. Then I still need to simplify that, so I'm going to write the exponent is x plus 1. Please, can you do me a favor? If you are doing maths, right? When you are doing maths, number 1, you must look at the board, what the teacher is writing. You must listen, and you need to write. Okay? Those 3 things are very important. Looking, writing, and listening. Okay? So I'm here now, times. This is 3 cubed, I can simplify this by distributing this 3 into x minus 2. Don't forget that this exponent here is a binomial exponent. So this 3 multiplies the x, also multiplies the 2. From my experience, some learners will just multiply this 3 by x, they forget to multiply the 3 by negative 2. It happens more often. So that becomes 3 to the power of 3x minus 6. Okay? Then all over 2 times 9, but 9 is a perfect square. It is written using a base of 3, so I can have 2 times 3 squared, all raised to the power of 2x minus 1. Then the next step now, I'm going to simplify further, so let me carry on here. From there, now here, I'm just going to add the exponent of the 3 is a 1, the exponent of this 2 is a 1. I encourage you to do that because some learners, they forget that this exponent x plus 1 also affects this 3. It affects both the 3 and the 2 squared. This exponent 2x minus 1 affects the 2 and the 3 squared. Okay? So from there, once I've done that, I'm going to simplify now. So this 1 here is multiplied by x plus 1. So I'll get 3 to the power of x plus 1 times. This is 2 squared. So the 2 times x plus 1 is 2x plus 2. So that will be 2 times 2x plus 2 times 3 to the power of 3x minus 6 all over. Okay? All over. Here, the exponent of the 2 is the 1, so 1 multiplies both 2x and minus 1. So I'll get 2 to the power of 2x minus 1 times 3, 2 times 2x, that's a 4x, 2 times minus 1, that's minus 2. Are you following? Then, once you get here now, you go back to your law 1 and law 2. Okay? If you are multiplying bases that are similar or that are identical, you just add the exponents. If you are dividing bases that are the same, you subtract the exponents. So here we've got this 3 and we've got that 3. So I can add their exponents. Okay? Then later I'm going to use law 2. So I'll start by using law 1 in the numerator. So this becomes, for this base of 3, since there is multiplication between those two bases, I can just add the exponents. So I can write this as 3, okay? X plus 3x will give me 4x. Okay? Then plus 1 minus 6 is going to give me minus 5. Times this 2 to the power of 2x plus 2. And that's all over 2. In fact, I'm going to start with the 3. So 3 to the power of 4x minus 2. Please, because of multiplication here, I can start with the 3 to the power of 4x minus 2. Then write that. That's 2 to the power of 2x minus 1. Okay? Once you get to that point there, let's use law 2. We are dividing bases that are the same, so we can subtract what? The exponent. So I'm going to move on to the next page. If you do it step by step, you won't make unnecessary silly mistakes. Yes? Sorry? No, you can't cancel out because the exponents are not the same. Okay? Even though there's 4x here, there's 4x here, but this minus 5 and that minus 2 are not equal. No, you don't. You can cancel out bases.
But even in minuses.
You listen. If you are dividing bases that are the same, you subtract the what? Exponents. Not cancelling out bases. What do you mean by cancelling out bases? Yeah, but you see, counting out bases now, it's not really the proper language. Okay? So let's use, let's get on. So that will be 3. We are going to use log 2. If you are dividing bases that are similar, you keep the base, subtract the what? Exponent. Okay? Alright, so that's 3 to the power of 4x minus 5. 3 to the power of 4x minus 5 minus, based on law 1, sorry, law 2 rather. I'm putting this minus here based on law 2. Okay? We are subtracting the exponents because the bases are being divided and the bases are the same. Okay? So we have to put the exponents, this 4x minus 5 here. Next you put minus, then this 4x minus 2 we put it inside brackets. So the next step, we put that 4x minus 2 inside brackets. It's a binomial exponent, so it has to be put inside brackets. Okay? Then times the base of 2. Okay, we have 2 to the power of 2x plus 2 minus, open bracket, 2 to the power of 2x minus 1. So I'll put 2x minus 1. Are you following? I'm using law 2 of exponents, and you were taught law 2 of exponents from grade 7 or 8. If you are dividing bases that are the same, subtract the exponent. Okay? So here is basic algebra now. 4x minus 4x. So those two cancel out. 4x minus 4x gives you what? 0. Right? Then minus 5 minus 2. That will give you minus 5 plus 2, which gives you negative 3. So we end up having 3 to the power of negative 3. Okay? Are you following? And then from there, multiply. Then here, 2x minus 2x gives us a 0. Then 2 minus 1, that will give us a 3. So we end up having 2 to the power of 3. We are not done. The question says simplify. To simplify here, because we have a negative exponent here, we have to convert it to a positive exponent using definition number 3. This one here. X to the power of minus n is equal to 1 over x to the n. That's definition number 3, based on what we did on Tuesday. Okay? Alright? Then from here, you can write this 3 to the power of minus 3 as 1 over 3 cubed times 2 to the power of 3. Don't forget that the dot means multiplication. Okay? So, what is 2 to the power of 3? It's 8. 8 times 1 gives you 8. All over 3 to the power of 3, that's 27. That's the final answer. Okay? Now, a question like this, 5 marks or 6. No. Because we do quite a lot. Okay? Any question? Some of you, when I'm telling you some of you like this, I can see you just concentrate 100% and lose now. If I don't lose concentration, then you must not lose concentration. You must not look up. Don't think you'll be happy to see me say, "One of us is then start the name, so one of us looking inside." If I'm not supposed to do that, then you are supposed to make sure that you concentrate, you look at what I'm doing. If you have a question, you are more than welcome to ask. Okay? I'm done. Any question before I carry on? If you don't have a question, then let me try to do the last one. I think the girl will try to, but I'll try to move quickly. Number 10. Number 10. Now with number 10, we are going to use factorization because there's addition there. So it's 3 to the power of x plus 3 to the power of x plus 1 all over 8. Make sure you pay attention here. Because this type of a question, from my experience of teaching this subject for many years, learners have got issues here. Okay? Because of this addition here, okay? Because of that addition, it should be a clue to you that you have to factorize, which means you need to create a common factor in the numerator. And by observation, what is likely to be the factor in the numerator? 3 to the power of x. But now, how do you create it? What you do is you go back to law 1. Okay, this is extremely important. Make sure you pay attention. Law 1 says x to the power of m times x to the power of m is equal to x to the power of m plus n. That's the first law. Okay, of exponents. And we introduce that, I think there's 7 or 8. Okay, now in this grade, you can move from the right hand side toward the left hand side. Generally, so far you've been moving left to right. In grade 10, you also move from right to left. So when you're doing questions on factorization like this one, it means you have to move from right to left. Okay? And don't forget that multiplication can be replaced by a dot. Don't forget that. Remember that. Right? So I can split this 3 to the power of x plus 1 using this law here. So this will be like the right hand side. Okay? So I can split it up and get something like that. Okay? So I'm going to do that now. You follow what I'm saying? So the next step will be 3 to the power of x plus 3 to the power of x times, okay, times 3 to the power of 1. This is the left-hand side of the first law of exponent, this one. That's the left-hand side of the first law of exponent. Okay, don't worry, I'm going to finish now, people. Don't think, So now that I've done this, I've used the first law, moving from right to left, I've created now the common factor, which you can see with your own eyes. Okay? So this is all over 8. Okay? Then I'll take out the common factor, which is 3 to the power of x. Then if I take out 3 to the power of x, I'll have 1 here plus 3 to the power of 1, which is the 3. That's all over what? All over 8. Okay? Then I can simplify what's inside the brackets. So I'll get 3 to the power of x, and I'll get 4 there over 8. My final answer is going to be 3 to the power of x over 2. Okay? Because there's a common factor between 4 and 8, and that common factor is the 4. 4 into 4, 1. 4 into 8, 2. But the 2 is going to be a denominator. Okay? Then we are done.